Hi everyone, this is Mrs. Greeny, and today we are going to learn about understanding line plots. To do this, let's look at a sample line plot. It's important to understand the terms of our line plot because it gives us more information and explains what our line plot is trying to tell us. It also provides us with the ability to get more specific and answer more in-depth questions relating to our line plot. The first thing we should always look at is our label. And our label can be found at the bottom of our line plot. And this label tells us what these numbers stand for or represent. So in this line plot, each of those numbers represent days. For example, this represents day 1, day 2, day 4, day 8, day 10. And each of those numbers represent or tell us a day. Another really important term that you will hear when working with line plots are data points. And each of these X's is a data point. Sometimes data points are not represented by X's. Sometimes they're represented by dots. But that is what they're referring to when they say, how many data points were there on day 8? Or how many data points were there total on your line plot? To get more information about data points, you sometimes have to read descriptions, like the one here. However, you can also sometimes have access to a key, which we have on this one. The key will often tell you what each of your data points represents. For example, in this one, each of our X's or data points represents one box. So we know that on day 1, there were 4 boxes of candy sold. And we know it's chocolate candy because in our description, it says Tom was selling boxes of chocolate candy. We also know that on day 5, only 1 box was sold. Can you figure out how many boxes were sold on day 10? Take a look now and see if you can figure it out. All right, did you figure it out? How many data points were there for day 10? 6, right? Tom sold 6 boxes of chocolate candy on day 10. Now let's look at some other types of questions we might get when working with line plots. So some of the questions we get when working with line plots will be more simple. They will only take one step and you might be able to answer it just by looking at the line plot. So for example, some of those questions include how many boxes of chocolate Tom sold each day. Just like we did on the previous slide, and we asked how many boxes were sold on day 10, and you said 6, right? That was a simple question where all you had to do was look at day 10 and count the data points. Another simple question you might get are how many total days did Tom sell chocolate? Can you figure out what we can look at on this line plot to tell us how many total days Tom sold chocolate for? All right, if you guess that you can look at your labels and see the total days, you were right. We know that Tom sold chocolate for 10 days. Now, another one we could ask is, what do my data points represent? What could you look at on this line plot or its description that tells us how many days or what each data point represents? Did you guess each box, your key? If you guessed your key, you're totally right. Our key told us that each X or each data point represented one box. Could you have looked somewhere else? Yeah, you could have. You could have looked at your description where it told us that he plotted the number of boxes he sold in the line plot below. Now, there is one more simple question, and that is, what is the purpose of this line plot? By looking at the description, the key, the labels, and our data points, could you figure out what the purpose of this line plot is? Do that now. I'll give you a few seconds to think about it. All right. Did you say that this line plot shows us the amount of boxes Tom sold in a 10-day period? If so, you're right. The purpose of this line plot is to tell us how many boxes Tom sold, either over a 10-day period or each day that he sold boxes. Now, just like there's more simple questions, we can also get more in-depth questions. And these questions will often mean that we have to do some math. So here are a few of those questions. How many total boxes of chocolate were sold? How much more chocolate was sold on one day than another? And what was the average amount of boxes sold per day? Now, I'm sure that you could come up with all sorts of different questions that we can get even more specific about our line plot. But these are just a few. Let's look at how we would solve some of these. How many total boxes of chocolate were sold? How do I know what to do here? Are there any clue words or target words that tell me? I'll give you a second to look at the question again and see if you can figure out what word hints at what operation we might use or a strategy we could use to solve for this one. I'll even reread the question. How many total boxes of chocolate were sold? All right, did you guess the word total? If so, you're right. The total tells us that we either can count up all of the boxes Tom sold, which might take a while. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We could do this counting all of the X's on our line plot until we've counted all of the data points through day 10. Now, another way you could do this is by using the operation of addition. The word target tells us that we can use addition to solve this question. What would we add? Take a second to think about what we would add to find out how many boxes total were sold. Did you figure it out? Did you say that we could add the amount of boxes from each day together and get our answer? If so, you're right. So let's do that now. Day 1 sold 4 boxes. Day 2 sold 3 boxes. Day 3 sold 8 boxes. Day 4 sold 5 boxes. Day 5 sold 1 box. Day 6 sold 12 boxes. Day 7 sold 11 boxes. Day 8 sold 10 boxes. Day 9 sold 7 boxes. And day 10, Tom sold 6 boxes. Now, take the time to add these up now. I'll give you a few moments to find your answer. All right, did you get the number 67? If so, you were right. And make sure you always include your units. So 67 total boxes. Let's look at another question now. How much more chocolate was sold on one day than another day? Now, take a second to see if in that question there is a clue word or a target word that can help us figure out what operation we can use to solve this. All right, did you say much more? If so, you were right. The phrase or question words much more tell us that we have to use the operation of subtraction. So let's look at days 3 and 4 for this one. And I'm going to circle both of them. Let's figure out how much more Tom sold on day 3 than on day 4. How many boxes did Tom sell on day 3? Did you say 8 boxes? If so, you are correct. So we would take 8 for day 3. Now, figure out how many boxes Tom sold on day 4. Did you say 5? If so, you're right. And now we know, based on the phrase much more, that we're going to have to subtract these two. So how many more boxes did Tom sell on day 3 than on day 4? Did you say 3 boxes? If so, you're correct. Let's look at our last question. What was the average amount of boxes sold per day? Take the time now to think about what clue word or target word tells us what operation we will have to use to solve this. Did you say average? If so, you're right. Average tells us that we have to divide. But there are a few extra steps when finding the average. So it may be more helpful if we write out a number model to help us solve. Our number model would look something like this. The total amount of boxes sold divided by the amount of days, number of days candy was sold. And we already know these numbers, right? Because if we look back, we figured out the total amount of boxes sold was 67 boxes. So we know that in our number model, we can put 67 for the total boxes sold. And we also know from our previous slide how to find the number of days that Tom sold. All we have to do is look at our label, and we know that Tom sold chocolate over a 10-day period. So we would put 10 here and then divide. Go ahead and do that now and see if you could figure out how many boxes Tom sold per day on average. Did you say 6 or 7? If so, you're correct, because 67 divided by 10 would give you 6, remainder 7.